Hello, my name is Mark Smith, N6MTS. I will be presenting at the QSO Today Virtual Ham Expo today on the Open Headset Interconnect Standard. But before we do that, let's talk a little bit about who I am. Again, my name is Mark Smith, N6MTS. I am the head cheese, or the CEO and president. I'm the guy for Halibut Electronics. You can find me on the web at electronics.halibut.com. I'm also the host of the Ham Radio, or a host of the Ham Radio Workbench podcast. You can find me on Twitter or YouTube as @SmittyHalibut. That's the handle I'm commonly known as. And similarly on Mastodon or the Fediverse as @Smitty@halibut.com. I've been a ham since 1992 in high school. And then I started college in 1993, and I spent the first 2 years as an electrical engineering student. But my third year, I switched over to computer engineering to add software to that, and that's what I ultimately got my degree in. I spent the first 30 years of my career, including time in college, in IT, as a network and Unix system administrator. In the last 7 years or so, I was in information security. But electronics was always a hobby of mine. I never left it very far behind. And last year, in 2021, almost exactly a year ago, actually, I left IT. And I started my own business called Halibut Electronics to make ham radio and audiophile electronic devices. My first big product is called SOAR, Satellite Optimized Amateur Radio. That'll be available in late 2022. But that's not what we're here to talk about today. Today we are here to talk about the Open Headset Interconnect Standard. What the heck does that mean? Well, let's start with the first one, open. Open means that any individual or company may make devices compliant with this standard, with no obligation, no licensing restrictions, nothing like that, right? I am encouraging everyone to use this standard in places that it makes sense. Headset. If this standard describes the signaling commonly found between the user and a radio, right? Things like the microphone, the headphones, or a speaker, and push-to-talk. Interconnect. It describes both the physical and the electrical connection of those signals between the user and the radio. And standard. Devices built to this standard will work with other devices built to the same standard, right? So Open Headset Interconnect Standard. Let's talk a little bit about standards. We have several standards in amateur radio, be they defined standards or just de facto standards. We have them for things like RF connections and power connections. For example, in RF, we have 50 ohm impedance coax or 450 ohm twin lead. Right? Those are electrical standards. For power, we use 13.8 volt DC, plus or minus 15%. That is a standard. Whether these have been defined as standards or whether they're de facto is somewhat irrelevant. They are standards at this point. For physical, we have a few different standards to choose from, but because the electrical is the same, they're easy to switch back and forth between. Right, so let's take a look at some RF standards. We've got the SO239, or the PL259, or the UHF connector, whatever you want to call it. We have N connectors, we have BNC connectors, we have all kinds of connectors. These are just some examples. And here's an example of what it takes to change from one standard to the other, right? Here's an adapter, they're very inexpensive, that changes between the SO239 and the N-type connectors. Because electrically they're the same, it's very simple to make a physical converter between the two. Let's look at power, right? So some power standard connections we have, physical connections we have, are Anderson Powerpole. We've got the 6-pin Molex, but they're not actually Molex. It's a different story. And these T-blade connections are used on mobile rigs a lot. These are used on HF rigs. And again, it's very easy to make an adapter to go from one standard to the other because the electrical standard is the same. It's literally just a cable with different connectors on either side. But let's look at headsets. We don't have such a standard for the connections that go between the user and the radio, right? Let's look at some of the differences, the different standards that we have. So many to choose from, right? Microphones. Well, is it a dynamic microphone or an electret microphone or even a carbon equivalent? If you use an aviation headset, that's a carbon equivalent, right? With your microphone, is it balanced or is it single-ended? What about the audio out of the radio? Well, is it a line level signal that would need amplification to go to headphones or a speaker? Is it a headphone level where it's already amplified for headphones, but you would need more amplification to make a speaker out of it? Or is it a speaker level, which would be too much for line level or for headphones? Is it ground referenced, or is it push-pull, right? You can have one of your signals, one of the lines be ground and the other one going up and down around it. Or, to make a more efficient amplifier, some speaker drivers do push-pull, where they drive both sides of the speaker out of phase, and you end up being able to increase your total power delivery by 4 times with the same voltage, right? So that's a thing that happens, and you can't plug a push-pull speaker output into something that's expecting ground referenced. Is it mono or stereo? Right, so there are all these different options available, and different radios use different solutions for this. For PTT, this one's a little bit simpler, but there's still 2 common standards that I'm aware of, at least. There's a simple contact closure to ground, or completing the microphone circuit, right? A lot of HTs, you will ground the negative side of the microphone to key the PTT. And that's not really compatible with the GPO style or GPIO style contact closure to ground. There are even more physical connections options to choose from. For the microphone, is it a 3.5 millimeter connection? If so, is it TS or TRS, right? Is it a 1/4 inch TS or TRS? Is it XLR? Is it the 8-pin round aviation? We'll be looking at those in much more detail pretty soon. Or is it an 8-pin modular like a RJ45 or a 6-pin modular? If it is one of those, even once you pick the physical connector, what's the pinout, right? The pinouts on these are just so different. We'll look at that in a lot more detail in just a bit. For audio out, similarly, is it a 3.5 millimeter or a 1/4 inch output? Is it TS or TRS? Or is it RCA? A lot of line level outputs will be RCA. For PTT, is it its own standalone 1/4 inch connector? Is it a 3.5 millimeter connector? Or is it one of the pins on the 8-pin modular microphone connector or the 8-pin round aviation microphone connector, right? There's so many different options to choose from that if you buy a headset and you try to plug that headset into the radio, there's a very good chance it's not going to work. So let's take a look at this example. This is the wonderful Heil Pro 7 headset connector, right? We got 2 3.5 inch, they call it 1/8 inch. It's 3.5 millimeter, sorry, not 3.5 inch, 3.5 millimeter plugs, right? There's the gray one, that's a TS. It has a tip and a sleeve, and that's mono for the microphone. They call it mono. It's a microphone. And then a 3.5 millimeter TRS, that is the headphone, right? And it's stereo. And they have a very simple adapter to go from the 3.5 to the 1/4 inch. So we got 2 different things there. But my Yaesu FT920, it's just the radio I have sitting right there, has one of these. I can't plug that into that, right? Well, the good news is Bob's got us covered, right? So Bob Heil sells the 81Y, which is a 3.5 millimeter here for the microphone. This is the PTT, not the headphones. The headphone connector goes straight into the radio, and then there's the 8-pin round aviation style connector right there, right? Okay, so we've got an adapter. That problem is solved. But let's say I've also got a Kenwood too, right? So it's got the same 8-pin round connector as the Yaesu does, but the pinouts are different. Pin 1 here is up, pin 2 is 5 volts, pin 3 is down, so on and so forth. Pin 1 here is mic, PTT is pin 2, and pin 3 is down. Well, at least that one's the same. But pin 4 is up, whereas pin 4 over here is fat. You get the idea. The pinouts are different, right? So something made for the Yaesu isn't going to work on a Kenwood, right? So how do I plug that into that? Well, good news. Bob still has us covered, right? He's made another adapter. Thankfully, they're color-coded, right? So that is the same connectors, same physical connections, but different pinouts. And thankfully, like I said, he's got them color-coded. The reds are for Kenwoods, right? Okay, that's starting to solve this problem. What about ICOM? Okay, we got another 8-pin round aviation. Surely that's going to be the same. Oh, no, never mind. It's yet a third pinout. Same connector, totally different pinouts. All right, fine. What about ICOM? How do I plug that into that? Surely Bob's got us covered. Yes, Bob still has us covered. This time it's blue, and it's, again, all the same physical connections, but a different pinout. But wait a minute. There's a different problem here. The ICOM expects a different electrical connection than the Kenwood or the Yaesu. ICOM expects an electret-style microphone. The Kenwood and the Yaesu use the dynamics. Okay, Bob still has us covered. He'll sell you an electret microphone element, but now that is much less convenient to swap out. If I want to move my headset between an ICOM and a Yaesu, I need to switch the microphone element, not just use a different adapter. Well, that's kind of a bummer. All right, so let's look at a different style headset. There is what I call the PC gaming style headset. The PCs have been using headsets for a long time. They started out as two different 3.5 millimeter TRS connections. They've recently kind of gone down to a standard where it's a single TRRS, so 4 pins on a 3.5 millimeter, and they're wired like this. Left and right audio, so your headphones are over here, this middle ring 2 is ground, and this sleeve over here is microphone. I still can't plug that into that, but at least I can make an adapter for it, right? So now I can make another adapter, but I've got 3 radios. So now I've got 3 more adapters. So for 2 headsets and 3 radios, I've got a set of 6 different adapters. And it's just kind of starting to get a little out of hand. Oh, one more thing. Remember how I said that the ICOM requires an electret microphone and the Kenwood and the Yaesu require a dynamic microphone? Well, those PC gaming headsets are electret microphones. And so if you try to send that signal into a Kenwood or a Yaesu, it's going to be too hot. Now, you can turn the mic gain down on the front panel, but it might still be too hot. It might overload the front end of that radio. And so you have to pad it down with some very simple circuit components here, but you got to add some components. It's no longer just an adapter. It's no longer just taking wires from one connector to another, right? So I got some bad news for you. That 3.5 millimeter TRRS, that picture is cropped. There are actually 2 different standards of 3.5 millimeter TRRS. One's called the CTIA standard. The other one's called the OMTP. Thankfully, electrically, they're identical. The only difference is the swapping of these 2. But when you buy a connector, when you buy a headset, unless you are explicitly looking for which pinout it is, you might get that wrong, and you might need to modify your adapters, right? The point being is that if you've got all of these different standards over on the headset side, and we've got all of these different standards over on the radio side, your adapter game has to be strong. You need to have all the adapters to go from everything on the left side to everything on the right side, or as many of the combinations that you want to have, right? It ends up being a full mesh of adapters. And if somebody off the street, if a friend of yours comes by, or you go into a shared environment where you don't necessarily know what all of the headsets are and what all of the radios are going to be, you may not have the right adapter. So how do we address this? That's the question that I'm trying to answer today. I propose the Open Headset Interconnect Standard. And what does that look like? Well, I'm going to say, instead of having one adapter between the headset on the left-hand side and the radio on the right-hand side, let's split this into 2 different devices. And I'm going to call them the user side adapter. The user side adapter is an adapter that goes between the headset and this Open Headset Interconnect Standard. That adapter is specific to the headset, and it stays with the headset. Ideally, someday, you might be able to buy a headset that just has the Open Headset Interconnect Standard connector on it natively. No adapter needed, right? We got to get some adoption first, but that is the ideal situation, is that there's no adapter required. In the meantime, we'll have adapters. But it's one adapter, and it stays with the headset, right? Then on the other side, we have what I call the radio side adapter. Again, it adapts from this Open Headset Interconnect Standard into whatever the specifics of that radio are. And it stays with the radio. You don't have to worry about what else is going to connect into you because you have this interconnect standard in the middle. As long as the headset can connect to a standard interface and that standard interface can connect to the radio, then you buy one adapter for every device and that's it, you're done. You don't have to worry about what it's going to connect into because as soon as it's on the standard interface, it can connect to anything else with that standard interface. Once we get some adoption, the radios may be built with the Open Headset Interconnect Standard natively on them. You don't need an adapter anymore. There may just be an RJ45 labeled OHIS on the front of the radio, and your headset with an OHIS port on it can just plug straight into that radio. That's my ideal future. In the meantime, we'll have to be making some adapters, and that's okay, because these adapters are relatively simple. You don't have to worry about all the different combinations. You know exactly what's on the radio side, and you know exactly what's in the standard. You make one adapter, and that problem is solved. All right, so let's look at a technical summary of what this standard is that I'm proposing. For microphone level, it's electret level, right? So the radio side is going to provide a 5-volt DC bias voltage down the microphone line, and on the headset side, it is over that standard at least, it is expecting it to be electret level. That doesn't mean that you have to have an electret microphone. You can have a dynamic microphone there or a carbon equivalent microphone, but the adapter that you make for that headset will contain all of the all of the conversion that is required to make it the same signal as an electret microphone. The audio from the radio going to the headset is going to be ground referenced headphone level stereo audio, right? So again, if your radio puts out something other than ground referenced headphone level audio, then the radio side adapter is responsible for converting whatever the radio puts out to this ground referenced headphone level. And then on the user side, if you want something other than headphone level, the user side is then responsible for converting it to whatever you want it to be on the other side. PTT, simple contact closure to ground. Most radios already have that anyway, so there's no conversion necessary there. But if you do have a radio that uses some other signaling method, you can convert it there. The Open Headset Interconnect Standard also specifies that the radio side will provide 5 volts DC, at least 200 milliamps worth, provided by the radio side to the user side for the user side to do like audio amplifiers or LED indicators or some sort of signal processing or whatever you might want to do that requires power. The radio side adapter will provide that power to the user side adapter. So electrically, that's what all of the signals are in that middle layer. Let's look at it physically. I've chosen the 8P8C modular connector. It's commonly but incorrectly known as the RJ45. Come talk to me afterwards if you want to go down that rabbit hole. It is an 8P8C modular connector, but everyone calls it an RJ45. The cable is going to be standard Category 5 or better. Cat 5e, Cat 6, Cat 7, Cat 8, whatever. It doesn't matter. But, standard twisted pair, 4-pair twisted pair cabling. Shielding, if you can get it, is ideal. That'll make things better. But the way the connector is wired, it shouldn't be necessary. We are using pairs intelligently to hopefully make this less critical. But if you can get shielded cable, that is definitely a better option. The wiring of those 8P8C modular connectors should be done as TIA 568A or 568B. If you're a network nerd, you know what this means. If you're not a network nerd you don't know what this means, don't worry about it. What it means is you can buy standard, common, off-the-shelf Ethernet cables. You don't have to wire up some weird standard or custom cable, any of that stuff. You can just buy off-the-shelf Ethernet cables. And if you know how to make an Ethernet cable, you know how to make an OHIS cable. 568A and 568B just talk about what pins get which pairs. And it's important for this because we have put certain signals on certain pins to make sure that they are on a pair, which will help with noise rejection. So electrically, it's an electric microphone, it's a headphone signal, it's a contact closure to ground for PTT, and you've got 5 volts, 200 milliamps available to you for any signal processing or amplification or whatever you want to do. Physically, it is an 8P8C modular connector, otherwise known as an RJ45. It's Cat 5 or better, shielded is preferred. They're standard Ethernet cables. All right, so what's the pinout? I'm going to show the pinout here as, you don't have to remember this now. There will be detailed documentation. The actual standards document goes into a lot of detail, but just a real quick summary. Here's an RJ45. This is how the signals are assigned to each of those pins. And if you've got a headset with headphones and an electric microphone and a PTT button, then this is the user side adapter, right? It is literally just wires straight through to the RJ45. You're just rewiring the connector to an RJ45 or to an AP8C connector. You're not even using the power. If you have a headset with a dynamic microphone, you can still do that. We just need to put the preamp right here. And the next slide, I'm going to talk about that. But otherwise, it is still a very simple adapter. You can get more complex here for more other types of things. If you don't want a headset there, if you want something else there, then it can get a little bit more complex. But the user side of these should be incredibly simple and incredibly inexpensive and easy to make. Let's take a look at that dynamic mic a little bit. So having a dynamic microphone is very common. Dynamic microphones and electret microphones are both incredibly common in amateur radio. Carbon equivalents are less so because they're aviation style headphones, but that's also still very easy to adapt here. But a dynamic is incredibly common, and it's about 15 to 20 dB quieter than an electret, so we need an amplifier. Well, since I knew this was going to be a common problem, and I had an idea of how to use the 5-volt bias voltage and the 2.2K resistor that the 5-volt bias goes through. This is a standard circuit you use to drive an electret microphone, right? And so here's the OHIS connection right here, and we got 5 volts and 2.2, and then the audio signal comes over here to whatever amplifier is in use. But using that resistor and that 5 volts, with these 5 simple, inexpensive components, you can make an amplifier that goes in line with your dynamic mic. And this is about a 15 dB amp. I think it's like 13.8 or somewhere around there. I can't remember exactly what the number is, but I did the math, and all of this is in the standard. A very simple 3 resistors, 1 capacitor, and 1 transistor, and that transistor isn't even all that critical. You can use a 3904 or 2222. Was it a 4001? I think is another one. Pretty much any general purpose NPN BJT transistor. This design is included in the standard for free use. So I have designed this amplifier. I mean, design is a strong term. I calculated good values here and I tested it out and it works. But you can use this free of charge, free of any licensing or anything like that. It's completely open for anyone to use. It's part of the standard. If you've got a better mic preamp that you'd rather use, by all means, use it. You are not required to use this as part of the standard, but it is included in the standard as an open and freely available piece of technology that you can use to take a dynamic microphone and bring it up to electric. Okay, that was a quick technical summary. For technical details, I'm going to provide links at the end of this presentation, and I've got some QR codes in there. The standards document is still a work in progress, but I've got it published right now. We've got a groups.io mailing list, and the GitHub repository is where the standards document and some of the design files I've been posting are. But we'll have links to that at the end. But before we do that, let's talk a little bit about when does it make sense to use the Open Headset Interconnect Standard? Well, like I described earlier, if you've got several different radios and several different headsets, and you want to be able to move headset from radio to radio, you can buy all the individual adapters, or you could buy or make Open Headset Interconnect Standard adapters, and now the adapters stay with the devices that they're adapting. It kind of becomes a simpler system. Or when you operate in a shared environment. For example, like at a field day, right? I'm going to bring my radio, my friend may bring their radio over it, and we've got their separate standards on it. But I'm going to have my headset that I want to use. My friend's going to have their headset, and we've got 5 other people coming to field day, and everyone's going to be sitting down at different radios, and I don't want to have your ear goobers in my ears, so I'm not going to be putting your headset on my head, or whatever, right? So everybody wants to keep their own headset, but move it from radio to radio. A club shack is another example where that's a common use case, or an EOC. Anytime that you are going to take your headset that you want to stay on your head and not be on anybody else's head and move it from radio to radio. Open Headset Interconnect Standard works really well in this. Or, in my particular case, if you want to design and sell a device that goes between the user and the radio and have it work everywhere without having overly complex input and output stages, right? Like if I'm building a device that goes between the headset and the radio, I don't want to have to make my headset connection totally generic to work on any headset, or my radio connection totally generic to work on any radio. I would much rather have a standard interface that I can build my device in the middle to and have all of the complexity pushed out to the other side. Gee, I wonder who might be doing something like that. All right. When is OHIS overkill, right? It's not going to solve every single problem. Well, for one case, if you've only got one radio or one headset, or any situation where that full mesh problem doesn't apply, OHIS is probably going to be overkill for you. I'm not saying that it's going to be the end-all be-all for all situations. If the full mesh situation doesn't apply to you, keep buying your one-off adapters. That's fine. Or if you've already got the adapters, and I'm not going to say that you have to go rush out and replace all your existing adapters with new ones just to be standards compliant. That doesn't make sense either. Or if you prefer the simplicity of a single adapter, right? Because OHIS does add some complexity between the headset and the radio, right? With a single adapter, you've got a single adapter. Here, I've got 2 adapters, and I've got another connection in between them. That adds a little bit of complexity. And if you don't think that added complexity is worth it for the other benefits, then don't go for it. All right, why did I make it an open standard? Well, open standards are how we get out of this mess. The reason we're in this situation is because nobody has proposed a standard before, or none of the existing common options have risen to the top as a de facto standard, right? And so if I were to make it a close standard, like this is the Halibut Interconnect Standard, then nobody else is going to use it, right? And then I've just made N+1 options, and that's no fun, right? I need to solve this problem for my own products, as I hinted at earlier, right? I'm solving this for future products that I'm going to be working on. And I'm not Gillette, right? I don't want to give you the razor and sell you the blade. I don't want to nickel and dime you on products that are not the value add that I bring to the table, right? I'm going to sell you on that product in the middle that actually adds functionality. But the adapters on either side, That's not where I intend to make a lot of money. I'm going to sell. I'm definitely going to be designing and selling OHIS adapters because you're going to need them for some of the products that I'm going to make in the future. And I just want to encourage adoption, so I will definitely make these available. But it's not where I intend to make a lot of money on it, right? That's not going to be the big money maker. If someone else came along and said, I can make those adapters for way cheaper than you can, Mark, I'm going to push you out of the market, I'd be like, great, please, because that's not my value add. Making these adapters is not my value add. I would much rather somebody else come along and push me out of that market. I don't need to be in that market. And it's a good DIY project, right? These aren't super complex, but there's enough meat in there, like that mic preamp or interfacing to the radio is actually going to be a much more complex, much more. It's going to be, there are more opportunities there for, hey, I'm going to go design a thing. Ways of making that useful and value adds, right? And so as a DIY project, I could totally see a club saying, all right, we are going to standardize on OHIS connections in our shack. And if you want to plug your own headset into this radio, we're going to do a group build. Bring your headset. We're going to build the user side standard interfaces. And, I just think it's a great project. And by making it open, we can encourage that sort of thing. All right, the infamous Learn More slide. All right, so if you want to take a screen cap now to be able to get those QR codes later, go for it. Otherwise, they're in the slides, as are the links themselves. But in general, look on GitHub for Halibut Electronics, Halibut-Electronics, and groups.io, look for Halibut-Electronics. If you can find those two things, GitHub and groups.io, look for Halibut-Electronics, you'll be able to find this sort of thing. And that's it. Thank you very much for coming to my presentation. I will start taking some questions now. Thank you very much for coming to my presentation. I'll talk to you later. 73s. All right. You are muted, Rod. Because of course you are.
You knew that would have to happen.
It has to happen at least once per presentation.
Very good, Mark. Thank you for the presentation. Super clear, super crisp. Really enjoyed that.
Thank you.
I'm going to feed a couple of questions to you as they come along. I've even got a couple of questions of my own.
Okay.
Bill, go ahead.
No, I was going to say, should I do the screen share with the QR codes? Do we want those up on the screen now?
Let's do that. Let's do that.
Select a window or a screen. Which is the one that I want? I think it's that one. Yes, that one. Allow. Excuse me. All right, so now the QR codes are up on the screen for your... nope, not that one. Because now the QRs are off to the side.
Oh, my. I hate when that happens.
Yeah, I think that's the one we want to be on.
Let's try it there. We're going to leave that up for a couple minutes while everybody grabs it.
Sounds good.
So, Bill, AC7SR is asking, how will you connect to an audio mixer?
So it depends on where you want the mixer in the system. So if you've got a conventional mixer and you want it to look like a radio to your headset, but then also have it look like a headset to your radios, then you can build some converters. Like we're talking about adapters here. And so you would have an adapter that goes from an open headset on one side, it would be the radio side of the open headset standard and connect out to the connections you need on that mixer. And then on the output of your mixer, it would adapt to a user side that would plug into the radio. Spoiler, I was talking about wanting to make devices that go between the headset and the radio. Well, guess what one of the first devices is that I want to make? There are various different forms of mixer. So the term mixer means one thing, and I think it gets used very loosely in a lot of ways in the amateur radio environment. So you actually have to talk about how you want to use a mixer. And I've got some ideas for products. And I hinted at I would really love to have an interface standard on both sides to be able to make those products a lot simpler. So having multiple headsets into one radio or one headset into multiple radios or some combination of that is a product that I intend to sell. Those products will not be open standards, they will not be open source, but the interfaces on those products will be, and that is kind of my personal ulterior motive to defining the standard, is to have that available and freely open and usable.
More of a comment from Margaret. Brilliant idea. Thanks for explaining the problem and solutions so clearly. And
thank you, Margaret.
You were commenting in the chat. Really crisp. It's something that Smitty does super well.
Thank you.
I do have a question for you related to the adapters.
Yes.
What kind of physical form factor are you thinking about these? Are these going to be cables? Because you could see these Lego bricks kind of lining up and a bunch of cord stress problems and that kind of thing. What have you got in mind?
So why don't you go ahead and make me bigger on the screen?
All righty.
Because I'm going to show a prototype. Yeah, there we go. So this is kind of the form factor I'm thinking for the user side adapter. You got a couple of plugs on that side. These are 3.5 millimeter. This one is designed to go to a Heil headset, right? So it's got a dynamic input. It's got that amplifier circuit inside that I talked about. This is screwed on. I'm not going to be able to take it apart. But the two plugs that you plug into a headset there, like a Heil headset, it's got the PTT on the adapter itself. So this is something that you hold in your hand as a PTT, and then it's got the cords coming out of it that go up to the headset, and then the other side of it is a shielded RJ45 or AP8C, and it's just a little pigtail of a cable. This plugs into the radio or mixer console or whatever it is. You have this in your hand as a PTT, and then your headset plugs into it. This is kind of the form factor that I'm thinking of for the products that I'm going to be selling. But honestly, you can do it if you've got a simple enough headset that doesn't require any electronics. This one's got a preamp in it, but if you got something that doesn't require any electronics, then you can just make it a simple adapter. On the radio side, I expect them to be bigger because you're going to need to have power coming. Well, some radios provide power in the mic connector, so you may not need a separate power input, but if you need a separate power input, there are going to be more cables. I'm kind of thinking that on the radio side, I'm going to have pass-through connectors. So I'll have the 8-pin modular male on the front panel of my radio adapter that I can plug my Yaesu standard mic into, and then it will have the output on the other side so that I can still use my Yaesu standard mic if I want, but I'll also be able to plug in an OHIS headset and switch between the two. Or maybe even have it automatically switch depending on which PTT is pressed, right? These are all the kinds of things that you can do. So on the radio side, I expect it to be a slightly larger module. Think like a West Mountain Radio, the rig interfaces. Rig Expert, I think is what they were called. On that size, that scale.
Excellent. Bill's asking, is it possible to use the audio output from the multi-DIN connector on the back of the radio? Can I share the audio with a sound card being used for digital?
So the mini DIN connector on the back of the radio, I'm assuming you're talking about the data port that was on a presentation I moderated yesterday. Somebody referred to it as the company screwed up and they all standardized on the same pinout. Because they never seem to standardize on this kind of thing. But they made a mistake and they standardized on the same pinout. So the data port, yeah, you absolutely can use that. It depends on how the radio treats that. Because on my Yaesu, you have to put it into a digi mode before it'll take the audio from that port. If you're just on SSB, it does not take audio from that port. It takes audio from the front panel microphone. So you might run into some problems there, but if you can configure your radio to say, hey, my audio is coming in the back side instead of the front side, then yeah, absolutely. There's no reason not to.
So really, this is more about interconnect as opposed to switching of sources.
Correct.
Right? So any switch sources would be an external box function?
Or inside the radio. Yeah, so the switching is the problem that Halibut Electronics wants to sell a product for, right? But when you get into okay, now I'm going to plug a headset into the switching box, and then I got to plug the output of the switching box into a radio. I was looking at what those interfaces were going to be for the headset and the radio, and I'm like, oh man, making this general purpose to work on any radio or on any headset is going to be a raging pain in the butt. And I wanted to find this standard. A friend of mine, Tom Tengden, WB9VXY, is actually the one who came up with the first version of this standard. So I want to give him credit because I'm building on his awesome work. He defined his standard in a very specific use case, in the EOC use case, and he proposed it to Aries as a standard. And it got traction in our local EOC. I don't think it got traction anywhere else. And he made a few technical decisions on the standard that I strongly disagree with, and we weren't able to come to a conclusion on that. So I'm taking his work and I'm building upon it and releasing it in a more general capacity. He envisioned it in one particular use case, and I really want to see it everywhere. So I'm building on his work. But yes, it is only for that interconnect. What the devices do that you plug that interconnect into is up to the device manufacturer. And that's the part that I'm going to keep proprietary because I'm using it to pay my bills. But the interfaces on those devices are what I am open sourcing, opening up as a standard and proposing that the industry use.
A question from Dave, too, is what about radio? Do all radios support +5 at 200 milliamp?
No. And so, well, the radio itself doesn't. Let me try that again. Some radios do, not all do. If you have a radio that does not have voltage output on the mic connector, then you're going to have to plug this adapter into its own 12-volt source for it to be fully compliant.
Cool. Okay. What's been the response of the headset manufacturers? Well, I'm not sure you've talked about this too much outside.
I have not. Exactly. Thank you, Dennis. No, this is my first presentation of this. I've talked about it a little bit on my private mailing lists, and I've kind of hinted about it on Ham Radio Workbench, but I have not talked to any headset manufacturers or amateur radio transceiver manufacturers, except for the fact that I am an amateur radio transceiver manufacturer. The early adopter units of SOAR are still using the 3.5 millimeter TRRS PC gaming headset standard, but discovery that these exist, which is an RJ45 modular plug that is a mid-plane adapter. That is to say, it doesn't sit on top of the circuit board. The circuit board goes halfway through, means that I'll be able to fit an RJ45 or an 8P8C into the small case that SOAR has. And once I discovered that these existed is when I said, okay, I'm moving forward with the Open Headset Interconnect Standard because the production version of SOAR is going to use this instead. So as an amateur radio manufacturer, I will be the first. SOAR will be the first one to support Open Headset Interconnect Standard off the natively.
And we didn't think there would be a part available we could order right now. So that looks like a really, really interesting part. Okay, well, how about this being used on HTs like ICOMs or others?
It can, certainly. The reason I didn't target HTs is because you don't typically tie an HT into a larger system. And that may not always, that if you are tying your HT into a larger system, like I've got a DMR HT that I'm going to sit in a cradle on my desk and I want to route its audio into a mixer or a switcher or whatever, then yes, we can absolutely do that here. You can make an adapter to go from an HT to Open Headset Interconnect Standard. That seems like a less common use case to me than with VHF, UHF mobile rigs at an EOC or HF rigs at a field day or at a club station or something like that. That seems like the more common use case, but there's nothing stopping you from doing it with HTs as well.
So for the lightning round, how much current does an amplifier circuit actually pull?
Like the one that I described, milliamps, single-digit milliamps. Incredibly low power. Think about it this way. You got a 5-volt supply and everything is in series with a 2.2 kilo ohm resistor. So at most it's going to be drawing, what is that, 2 milliamps, 2 and some change milliamps. Like if you shorted your microphone input to ground, the most that's going to be able to pull is, I think, 2 milliamps, 2 and change.
So, Jed, thank you for the compliments on Mark's desk. We will be having Workbenches of the World as an upcoming segment on.
Oh my gosh. So really quickly on this one, go check my Twitter stream, because just within the last few days, I posted a video to Kinesis, the maker of very good ergonomic keyboards. This is a total tangent. They make amazing ergonomic keyboards like this one. This is called the Kinesis Advantage, but they just released a new keyboard called the 360, and I posted a picture of my 360 at my desk, and they're like, "Is that your real desk?" And I'm like, "Oh yeah, you haven't seen my office." And I did a quick video tour of my office, of the absolute disaster area that is my office right now. I'm building a shop in my backyard, and within a few months, hopefully I'll be able to move all of this into a space that's about 3 or 4 times the size.
So if I'm reading this next question from Dennis correctly, what are there amateur radio headsets like from Heil that allow you to work with your really, really nice headset on your often really cheap interface to your Windows 11 PC?
I don't know the headset market well enough to say there is or is not. I know there are some really good headsets that are designed to work with a PC. If the amateur radio headsets are typically designed to go work with amateur radios, not with PCs. So what you would need is something to adapt it to that CTIA headset standard, because that's what most PCs these days are using. All the laptops I've owned for the last couple of years have had a single 3.5 millimeter plug, and it's 4 pins, left audio, right audio, ground, and mic. And so if you can adapt, and that microphone is expected to be an electret, not a dynamic. So if you've got a Heil headset with a dynamic microphone, you'll need a preamp circuit like the one I presented, and that's in the standard and free for anyone to use, whether you're using the standard or not. You'll need a preamp to bring that dynamic microphone up to electret. The good news is the PC is providing that 5 volts because it's needed for electret. So that preamp, in fact, that's how I tested my preamps, is I plugged this dynamic microphone, which is a Heil, just a different form factor, into a PC, and did some recordings, and it worked great.
It may be worth looking at the Heil website, because some of their portable headsets
Are electret.
have adapters that would go to not only PC interfaces, but even the old style cell phone interfaces.
Which is the same.
And
the 4-pin TRRS is the Apple. Most mobile phones, there were a few Nokias that used the other standard, but most mobile phones use the same standard as what the PCs are using these days.
They even had one that had that little tiny TRS style connector for a while there.
Yeah.
Alrighty. So let's talk to Stan, who's saying, what about the radio side if you're using Flex or Smart SDR? So
if your radio interface is a computer, there's nothing stopping you from making a radio side Open Headset Interconnect Standard that connects to a computer. And spoiler, it's on my backlog of products to make. The hard part there is PTT, and so I don't know how Smart SDR triggers PTT other than through the user interface. I have a Flex, but the only Flex UI I have is my phone, because I don't run Windows, so I run Linux. So I don't have a lot of experience of using the Smart SDR software on Windows. If there is a way of triggering PTT, then your radio interface, the radio side of the Open Headset Interconnect Standard interface, connecting to the PC, whatever that trigger mechanism is, it would have to implement that.
Hey, speaking of confusion, are you concerned that the RJ45 from the Yaesu radios and your own OHIS connector will get confusing?
No, because Yaesu is not the only one that uses RJ45, right? My Kenwood D700 is using RJ45. ICOM, I'm sure, uses RJ45 somewhere. We already know that there are lots of these out there. It's a good point. I'll probably add to the standard that OHIS ports should be clearly labeled as OHIS ports. You know what? I'm going to take a note on that, because that is a good point to avoid confusion with existings.
There is something to look at there as precedent. And Microsoft led a multi-vendor initiative that I was part of years ago, the PC 97 standard. You know, when you look in the back of your PC and there's a pink port and a little light green port and everything else?
All those colors.
That was my group that came up with the initial research for that, for what, that, hey, we can use colors to do this, because we did a whole bunch of focus groups on PCs and families setting up PCs, and how do you eliminate the insanity that is having a common North American family set up a PC together without divorcing each other.
Thank you for that feedback, though. I will add that to the standard. That's a good point.
Okay, my Yaesu FT991A and an inexpensive headset, apparently electric. I need to reduce my AF gain to 15, but when it's good with a hand mic, my new Heil Pro. This was a really long one. Let me read it from the original.
So I think I get the understanding. So when you're plugging an electret microphone into a radio that is expecting a dynamic, you have to turn down the mic gain. So yes, that is true, except that the radio side adapter of the Open Headset Interconnect Standard is plugging into a radio that it knows about, and it's going to stay with that radio. So since I've got an electret level signal coming in, and it knows that the radio it's connecting to is expecting dynamic, all it has to do is put a 15 dB pad. Excuse me. You make it an electrical 15 dB pad, and you also need to block the DC voltage, by the way. So you're going to have three components there. 2 resistors for a voltage divider to bring the voltage down, the signal down, and then a capacitor to block DC, because otherwise you're going to be feeding that 5-volt DC into the front end of your radio, which is expecting ground-referenced mic audio. So, but the point is that adaption, I'm sticking with that word. Rod and I agreed that adaption is a real word. So that adaption between the electric signal coming in the front, the OHIS, and the dynamic level signal going out to your radio, the adaption for that happens in that adapter that goes between the standard and whatever your radio is expecting. So the goal is, you shouldn't ever have to adjust your mic gain, or at least not very much, maybe a little bit here or there, just from the different sensitivities of each of the microphones. But you shouldn't have to take it from 50 down to 15 and then back up to 50 every time you change a headset.
When you talked about this on Ham Radio Workbench, I was wondering how you'd map the 5 signals into 4 pairs. Very clever to put the VCC and PTT on 1 pair.
So yes, one of the keys is that I made sure to keep all the grounds separate. The mic and mic ground are their own. The headphone left, headphone right, and headphone ground are their own. And then there's VCC, power, and PTT. And VCC ground, those two provide the power, and PTT uses the power ground. So the mic has its own return path. The headphones have their own return path. But it is pointed out in the standard that the radio side device must survive all 3 of those grounds being tied together on the user side. You cannot DC offset one of your grounds. You must expect those grounds to be tied together on the headset side. Benefit if they're not, but some headsets have to, like those 4-pin TRRS headsets I was talking about. The headphones and the microphone share a ground. So your headphone ground and your microphone ground are going to get tied together. There's no way to avoid it on one of those PC gaming headsets. So you have to be able to deal with that. But yeah, so now we've got, left audio, right audio, microphone audio, PTT, plus 5 volts, and power ground, plus mic ground and headphone ground, and that's your 8 signals, your 8 wires on the RJ45.
And by the way, when it comes to the standards documentation and the preamble and the definition parts, I do expect to see the term adaption.
Adaption, I will add it. I will add that to the glossary.
Really, really important.
Yeah. Hold on, making note. Adaption to glossary. Got it.
Okay. I think Kenwood puts 8 volts
Yep.
on the 8-pin socket. Not sure about the current rating.
It does on the D700 at least, because that's the Kenwood that I have the most experience with, and I know there is 8 volts on it, and I want to say it's 200 milliamps, which is where I pulled the number 200 milliamps out of a stinky hole. Honestly, I can't imagine ever needing that much power unless you're going to do a headphone amplifier. 200 milliamps at 5 volts is what, 1 watt? So that should be plenty to do a headphone amplifier on the other side. But like any signal processing that you're going to do is just going to require small numbers of milliamps.
Very good. Bill remarked that making an adapter for law enforcement radio in an EOC will be difficult. I will add that getting law enforcement to add anything to their issued radios is going to be just about impossible, but might be worth it.
I think the difficulty is going to be getting them to let you connect into it. If you know what those signals are, and spoiler, they're all commercial radios and they're probably pretty well published, making the adapter won't be difficult, but getting them to allow you to connect to it is. In our local EOC, we have a very good relationship with our served services, and we also have our own radios in there. And so, in fact, a lot of our radios in the EOCs are all commercial rigs, honestly. So,
yeah, good point. Telephone industry, and this is going back years ago, folks, with like office headsets, was very good about standards in the office for many years. Really made things straightforward.
Yep.
And I think this is ultimately what Mark's getting to, is we have been really negligent in ham radio and bringing this standard forward. So it's one of those. I got excited about Mark doing this.
Fun fact, go look at the center 4 wires of the 8P8C. That is the same standard as a handset, a telephone handset. In fact, that's why Tom chose those as the center 4 wires, because it was a handset standard, and he could test some devices by taking a standard telephone handset and plugging it in. Handsets use carbon equivalent, which I think is one of the reasons why he chose carbon equivalent as the microphone standard instead of electret. But in a amateur radio environment, that doesn't make sense to me, because every single microphone you use, unless you have a aviation headset, is going to need an amplifier, and that just doesn't make sense to me.
Alrighty. Hey, by the way, we have 3 votes, and now the standard is standardized.
Adaption.
Adaption.
Adaption is a verb. Got it. Done. It's in the glossary.
Okay, and look what's come up here. George is asking, are you considering the assignment of pins to match Ethernet twisted pair for self-shielding?
Yep. Exactly. So you'll note that the only one that matters is the microphone. The microphone is by far the most sensitive signal to noise rejection, and it is on pins 3 and 6. And that is pins 3 and 6 are a pair. It happens to be the green pair in 568B. I can't remember what color it is in 568A. But microphone and microphone ground are on a pair. That's why I specify that 568A or 568B is the wiring, because we want to make sure that pin 3 and 6 are a pair. 4 and 5 are the headphones, but headphones are much higher power level that you're not going to pick up any noise, and they're not feeding an amplifier anyway. So, but it's also on a pair.
All right. And we're in the last couple of minutes, folks. If you have any last questions to sneak in, we're going to try to keep to being on time. The nice thing about standards is there's so many of them. The manufacturer wants to lock you in, and we could not agree more.
Yep.
About that. The whole point is to, and I love the way Mark has approached this, with an opportunity for him to make money, which is awesome, building value add things, but still having a standard that everybody needs.
Yeah.
Alrighty. And I have an aviation headset. How hard is this going to be?
So not very. The headphones are standard. Well, it depends. I suppose it depends on the aviation headsets. All the ones that I've seen and looked at the documentation for, the headphones are standard, so you can just plug those straight through. The microphone is probably a carbon. Carbon requires a DC bias voltage like an electric does, but it has a higher signal. So you need to pass the DC through to power the microphone element, but then you need to pad its level down. And so 2 resistors and it's a little bit more complicated with the capacitor, but it can be done with completely passive electronics. So you will be able to plug in your carbon equivalent microphone into an adapter. You'll need to have a specific user side adapter meant for aviation headphones with carbon equivalent microphones with that circuit in there, but it's totally simple and cheap and easy to do.
Okay, well, that brings us to the end of our time. Thank you so much, Mark. This has been...
Did I lose Rod, or did everyone lose Rod? Ruh-roh. Okay. Well, in hopes that
very
y'all
enlightening. I'm really looking forward to seeing more of this.
Either you froze or I froze. I'm not sure which.
No, I think we're just winding it up here.
And now I can't.
Okay.
I will be over at the ham radio workbench area in the area over there. So come see me over there if you want to talk more. See y'all later.
Thank you. Take care.